Hello. Okay, student, in this particular video, we are going to, in this video, we are going to discuss the concept of limit, especially the case of function of several variables. So firstly, we'll start with the basic concept. So firstly, we need to know about the concept. What is the distance between the 2 points in a plane? Understand the concept of the limit of a function. The first thing is we need to know how to find out the distance between the 2 points. In a plane, right? So suppose that we are considering a plane, xy plane. This is our x-axis, this is our y-axis. Say this is our origin, and I'm considering any 2 points in this plane. So this is a point x1, y1, and say this is our point, say x2, y2. So I want to find out the distance between the 2 points. Okay. So what is the distance between the 2 points, say AB? So to find out the distance between the point, what can we do? If we simply draw perpendicular from this point, then this point is x1 and this perpendicular distance, this is our y1 at this point, right? And also we draw perpendicular from this point, so this point is x2. Basically, this distance is x2. Otherwise, this coordinate is x1 0 and this coordinate is x2 0. Okay, and this particular point is y2, or we can say that its coordinate is 0 by 2, and this height is y2. This height is also y2. And if we join this point, say this is a point C, then this is x1, this is x2. So this particular distance AC is x2 minus x1. And because this height is y2 and this height is y1, so automatically this particular distance is y2 minus y1. And now it is a right angle triangle ABC. So in a right angle triangle ABC, AC AB scale in right angle triangle ABC, AB square is equal to AC square plus BC square, right? So the value of AC square means x2 minus x1 square, and BC means y2 minus y1 square. So this is the value of AB square. So what is the value of absolute value of AB? That is the distance. It is given by square root of x2 minus x1 square plus y2 minus y1 square. So this is the distance formula. So if we want to find out the distance between the 2 point AB. So if A has a point x1, y1 coordinate and B has a coordinate x2, y2, then we can find out the distance between the 2 point AB, which is given by this particular formula, right? Okay, now the second concept which we need for this particular topic is the neighborhood of a point. The neighborhood of a point. Okay, to understand the concept, let us suppose that we are considering a real line, right? So this is a real line, say x-axis. So somewhere here we have a point 0, and I'm considering any point here on this particular line, say x 0. So when we say that the neighborhood of a point in the real line, then the neighborhood of point is either lies in the left hand side or is in the right hand side. So this is the left neighborhood of a point and this is the right neighborhood of a point, right? So if I say that I want to find out the delta neighborhood of a point, so it means that the distance between the point, the neighborhood point from the point x naught is delta. So if this distance is delta and this distance is delta, so automatically its neighborhood point is this point is x naught plus delta and this point is x naught minus delta. Okay, so if I say that x is any point, then the neighborhood of a point is given by the distance x minus x naught is less than delta. Or we can say that because the absolute value of this difference is less than delta, it means that minus delta is less than x minus x naught is less than delta, or x naught minus delta is less than x is less than x naught plus delta. Okay, so it means that x belongs to the interval x naught minus delta and x naught plus delta. So this is called the open neighborhood of a point. This is called the open neighborhood of a point. And if we consider the deleted neighborhood of a point, deleted neighborhood of a point means we are going to consider all the neighborhood point of this point except the point itself. And it is given by the deleted neighborhood of a point, the deleted neighborhood of a point. It means that we are going to consider all the point lies in the neighborhood of a point except the point x naught itself. It can be written as 0 is less than x minus x naught is less than delta. Okay, so it means that because this we know that the absolute value is always positive, is always greater than or equal to 0. But if I say that it is greater than 0, it means that x can never be equal to x naught. So it means that the neighborhood of a point containing all point x naught minus delta to x naught plus delta except the point x naught. X will consider any point in the neighborhood of the point, but we are not going to consider the point x naught only. So that is called the deleted neighborhood of a point. So this is the concept we have discussed for the real line, that is for one variable function. But now we are going to extend it for the two variable. So what does it mean? Suppose that I'm considering any point, say x naught, y naught in a plane xy. So this is the point x naught, y naught. Now this time I am interested to find out the neighborhood of a point, or you can say that the delta neighborhood of a point x naught, y naught. So the delta neighborhood of a point x naught, y naught means it means that all those points which lies within a delta distance from this particular point. Okay, so what does it mean? It means that if I say that x, y be any point which is a neighborhood of this particular point, then the distance between these two points is less, is delta. Okay, and but if I say that this point is in the neighborhood of a point, so in this case, because the point lie in a plane, so in this case, its neighborhood of a point lies anywhere. It may be this side, it may be this side, maybe this side, maybe this side, maybe this side, anywhere. Okay. So in simply, I can say that the neighborhood of a point is a circle whose center is the point x naught, y naught, and a radius is delta. Okay. Otherwise, I can get this particular concept because I'm saying that the distance between the point and this particular point is a delta. It means that using the distance formula, it means that x minus x naught square plus y minus y naught square. It should be less than delta. Then we say that this is the delta neighborhood of a point. But if we're squaring both sides, it means that x minus x naught square plus y minus y naught square is less than delta square. So what this equation gives us, this is nothing but the equation of a circle. This is the equation of a circle whose center is the point x naught y naught, and radius is delta. Okay, so basically this gives us the interior of the circle. Interior of the circle. That means we are going to consider all the points lie inside the circle, excluding the point on the boundary of the circle, because we are considering the open neighborhood of a point, open neighborhood of the point x naught y naught. Okay, so this is the concept of the neighborhood of a point. So in a plane, when we talk about the neighborhood of a point, then we say that the neighborhood of a point is a circle whose center is the point x naught y naught and radius is delta. Okay, and if we talk about the deleted neighborhood, so deleted neighborhood of a point means we are going to consider all those points which lie within the neighborhood of this point except the point x naught y naught. So it means that 0 is less than square root of x minus x naught square plus y minus y naught square is less than delta. Okay. Basically, the concept of deleted neighborhood is required in the concept of limit of a function. For example, suppose I consider the problem of a limit that limit x approaches to 1, x square minus 1 upon x minus 1. Okay, so suppose that this is our function. So here I want to calculate the limit of this function at point x equal to x approaches to 1. So in this case, we can consider all the neighborhood of a point which are nearby 1, but we have to exclude 1 because at x equal to 1 your function is not defined. So in this case, while solving the problem of the limit, we generally consider the deleted neighborhood of a point rather than the neighborhood of a point. Okay, so what is the meaning of this part? If I want to calculate the limit of this function, it means that whenever x approaches to 1, what will be the limit of this function? So in this case, I can consider the neighborhood of a point 1 as 0.9999. This is the neighborhood of a point 1. So if I replace x equal to this, then what is the value of the function? X square minus 1 upon x minus 1. This is 0.9999 whole square minus 1 upon 0.9999 minus 1. So either I can take the square of this number, or what can I do? I can simply write it as a square minus b square. That is 0.9999 minus 1 into 0.9999 plus 1 upon 0.9999 minus 1. Obviously, this difference is not equal to 0, so we can cancel it out. So its value comes out to be 1.9999. Means if the value of x is very close to 1, then the value of the function is approximately 2. So it means that the limit of this function is 2. Okay. On the other hand, instead of the left limit, I can consider the right limit, because when we consider the real line, then the neighborhood of a point either lies in the right hand side or in the left hand side only. These are the only two possible neighborhood of a point. So if I choose x equal to 1, say 0.00001, this is also the neighborhood of a point. So if I substitute here, then x square minus 1 upon x minus 1, so it means that 1.00001 whole square minus 1 upon 1.00001 minus 1. Again using a square minus b square formula rather than calculating the value of the function. Okay, so I'm simply using the algebraic identity here. Again, this difference is not equal to 0. So we cancel out this factor with this. So its answer comes out to be 2.00001. So what does it mean? When the value of x is very close to 1, then the value of the function approaches to 2. So it means that the limit of this function is 2. Okay. So in this case, we can take any neighborhood of a point other than the point x equal to 1. So that's the reason when we calculate the limit of this function, then how do we solve it? We can say that limit x approaches to 1 x square minus 1 upon x minus 1. This is limit x approaches to 1. Okay, let me write it in the next slide rather than on the same slide. So how do we calculate the limit of this function? This is x square minus 1 upon x minus 1. So this can be factorized it as x minus 1 into x plus 1 upon x minus 1. And we cancel out this factor because x approaches to 1. X is not equal to 1, right? So now, because your function is defined at the point 1, so I can substitute here the limit. So the limit of this function comes out to be 2. Okay, so this is the concept of the limit of the function. So this is the case of one variable function, right? But we need to understand that how do we find out the limit of the function for two variables, right? So let us start with firstly the definition of the limit. So the definition of the limit is in case of two variable, we can say that xy approaches to x naught y naught, f of xy, this is equal to L. This is the limit of the function. Okay. So if we define it, then we can define it in this way for any given epsilon greater than 0, however small, there exists a real number delta greater than 0. Again, we are assuming it to be a small number such that mod of f of xy minus L is less than epsilon whenever 0 is less than square root of x minus x naught square plus y minus y naught square is less than delta. Okay, so what is the meaning of this statement? Basically, I have simply expressed this particular expression here in this form. So we have chosen a number epsilon, which is a very small number, but it is a positive number, right? So we are saying that the difference between fxy and L, this is very small, even less than a very small number. So when we say that the difference between the two number is very small, for example, I say that 2 and 1.9999. So what is the difference between these two? It is 0.0001. So this is a very small number. So I'm saying that the difference between these two numbers is very small when x minus x naught square plus y minus y naught square is less than delta. And what is this? Like we have already discussed the neighborhood of a point. We have already discussed the definition of the neighborhood of a point. So it means that whenever we choose the point xy, which is very close to the point x naught y naught, that means whenever we choose the point in the neighborhood of a point x naught y naught, so if this number is very close to the point x naught y naught, automatically the difference between these two numbers is less than a very small number. So this is the definition of the limit of the function. Okay. So like in the last problem we have discussed, sometime it is not necessary that your function is defined at the point x naught y naught. So that's the reason while solving the problem of the limit, we generally use the deleted neighborhood of a point rather than the neighborhood of a point. So we are using it greater than 0. So now let us consider some problem based on the delta epsilon approach. Let us consider some simple problems here. So suppose the question is using delta epsilon approach, establish the limit xy approaches to 1, 2, x square plus y square plus 3. This is equal to 8. Okay, because in this case, your limit of the function is defined. If I want to calculate it, because your function is defined at the point xy, I can simply calculate the limit as 1 square plus 2 square plus 3. This is 1 plus 4 plus 3 is equal to 8, right? But we need to prove this particular limit concept using delta epsilon approach. So what we need to do in this case? So for the solution part, so this is our function f of xy. So I simply compare it with xy approaches to x naught y naught. F of xy is equal to L. So what is our f of xy here? So here f of xy is equal to x square plus y square plus 3. Here limit L is equal to 8. Okay. So now to establish this particular limit, we start with the definition. So we state that let epsilon be greater than 0 be any given number which is very small. Okay, consider f of xy minus L is less than epsilon. So we are assuming that, suppose that this is given to us, that epsilon, we have already chosen epsilon, okay, which is a very small number, such that the difference between these two is less than epsilon. X square plus y square plus 3 minus 8 is less than epsilon. So what we have, x square plus y square minus 5 is less than epsilon. So I want to find out the relation between the delta and epsilon so that the difference between these two is less than epsilon. Okay. So what we are going to consider, let delta greater than 0 be any real number such that 0 is less than square root of x minus x naught square plus y minus y naught square is less than delta. Basically, we are going to consider the neighborhood, relative neighborhood of a point. So what is x naught here? Here x naught is 1 and y naught is 2. So it means here we have x minus 1 square, y minus 2 square, and this whole term is less than delta. Okay, one more thing, because we are considering the relative neighborhood of a point, and we know that square root of a number is always positive. So square of number is always positive. So it means the minimum value of this particular part is 0. So if this number is 0, it means that square root of y minus 2 whole square is less than delta. So it means that it also implies that mod of y minus 2 is also less than delta. It also implies that x minus 1 is also less than delta, and mod of y minus 2 is also less than delta. Okay, because if x minus 1, I assume it's 0, then it means that mod of y minus 2 is less than delta. And if I assume y minus 2 equal to 0, it means that x minus 1 mod is less than delta. Okay, so basically we'll get these three conditions. So with the help of these three conditions, I want to reduce this particular expression in term of delta. So, and by comparing it with this one, it will gives us a relation between delta and epsilon, right? So we consider mod of x square plus y square minus 5. So because we are given condition in term of x minus 1 and y minus 2, so because I want to express this expression in term of delta, so firstly I need to convert this expression in term of x minus 1 and y minus 2. So what can I do? I'm going to replace x square as x minus 1 plus 1 whole square, and I can write y square as y minus 2 plus 2 whole square, and this 5 is already there. Okay, so I am assuming it like a plus b whole square, a plus b whole square. So if we use this identity, it will gives us x minus 1 whole square plus 1 plus 2 times x minus 1 using identity a plus b whole square. A plus b whole square as a square plus b square plus 2ab. So this is the first part, and similarly here also we are using the same identity y minus 2 square plus 2 square, that is 4, plus 4 times y minus 2. What is a? This is y minus 2. What is b? It is 2. A square plus b square plus 2ab. Okay, minus 5. Now here you can see there 1 plus 4. This 5 and 5 get cancel out, and if we again rewrite this expression, I can consider it as x minus 1 square plus y minus 2 square plus 2 times x minus 1 plus 4 times y minus 2 more. Now we are going to use the property of modulus, that mod of a plus b is always less than or equal to mod of a plus mod of b. So we are going to use this property here. So if we use this property, then we have mod of x square plus y square minus 5. This is the part from where we have started, and we now reach up to the point x minus 1 square plus y minus 2 whole square plus 2 times x minus 1 and 4 times 2 times x minus 1 plus 4 times y minus 2. Now this is less than or equal to mod of x minus 1 square mod of y minus 2 square plus 2 times mod of x minus 1 plus 4 times mod of y minus 2. Now mod of x minus 1 is square is same as x minus 1 square, because square of a number is always positive, right? So this expression is same as this one, right? Now according to the given condition, so we have x minus 1 square plus y minus 2 whole square is less than delta. It's square root. So it means that what is x minus 1 square plus y minus 2 whole square? This is less than delta square. Okay. Obviously, it should be positive if I'm considering the deleted neighborhood of a point, but here it is not required because your function is defined at the point x naught and y naught. Okay, but generally for the limit problem, we are using the deleted neighborhood. But because in this case your function is defined, even we can take the neighborhood of a point also. So according to that, this particular part is a less than delta square, and x minus 1 is also less than delta, y minus 2 is also less than delta. So this is less than, about this is less than 2 times delta, and this is 4 times delta. So basically this is delta square plus 6 delta. Okay, or delta square plus 6 delta, this can be written as, if we use the concept of completing the scale, then delta square plus 6 delta, this can be written as half the coefficient of delta, that is 3, its square 9, adding and subtracting. So this will gives us delta plus 3 whole square minus 9. Okay, so I can write it as this is equal to delta plus 3 whole square minus 9. And we have already assumed that this is less than epsilon. So either I can assume it as that this is also less than epsilon, or even I can assume it equal to sign also. Okay, because our main purpose is that this particular expression is less than epsilon, right? So in this case, it actually gives us the relation that delta plus 3 whole square, this is less than epsilon plus 9, or what is the value of delta? epsilon plus 9 its root minus 3. Okay, so this is the relation between delta and epsilon. Okay, sometimes we write equal to, we write the sign of equality, or we can write less than also. So basically, what is the relation? That the value of delta should be less than epsilon plus 9 minus 3, because epsilon is a very small number. So it is approximately 0. So 0 plus 9 is 9, or its root is 3. So it means that the difference between these two is very small number. So it means that we need to choose delta to be a very small number. So it means if the value of delta is very close to the point 1 and 2, then the limit of this function is equal to 5 only. Okay, so this is the relation between delta and epsilon here. So this is how we can establish the limit. Okay, right. Now let us consider one more problem based on this particular concept. So suppose the question is limit xy approaches to say 0 0. So we need to establish x square plus y square into sine of 1 upon xy. This is equal to 0. Now again we need to establish this limit using the concept of uh, limit, that is we need to prove it using delta epsilon approach, using delta epsilon approach, right? So what can we do here again? So we consider, so let epsilon be greater than 0 or small. Let epsilon greater than 0 be given, where epsilon is a very small number, right? Such that mod of f of xy minus L is less than epsilon. So here, this is your function f of xy. This is your limit L, right? So what does it mean? It means here mod of x square plus y square into sine of 1 upon xy minus 0 is less than epsilon. So this is further equal to x square plus y square into sine of 1 upon xy is less than epsilon. Okay, so now we are going to consider let delta greater than 0 be any real number, any real number such that 0 is less than x minus x naught square plus y minus y naught square is less than delta, or it means that 0 is less than x minus x naught is also less than delta, and 0 is less than mod of y minus y naught is also less than delta, right? Means we have considered the relative neighborhood of a point. Why? Because in this case the neighborhood of a point 0 0, if I put x equal to 0, sine 1 upon 0 is not defined. So we need to consider the relative neighborhood of a point. So what is x naught? 0. Y naught is also 0. So it means it is 0 is less than x square plus y square is less than delta. And from here we get 0 is less than mod of x is less than delta, and 0 is less than mod of y is also less than delta. So with the help of these three conditions, I want to prove that this is less than a very small number, right? Now let us consider mod of x square plus y square into sine of 1 upon xy. So using again the property of the modulus function, that mod of a into b is always equal to mod of a into mod of b, and mod of A is equal to A if A is greater than or equal to 0, right? So because this is equal to mod of x square plus y square into mod of sine of 1 upon xy, and because x square plus y square is always positive, so this is x square plus y square times mod of sine of 1 upon xy. Now, again, we are going to use one concept that sine is a bounded function. Sine is a bounded function and its value is always less than or equal to 1. So if we use this concept here, then we can say that this is less than or equal to x square plus y square because the value of sine is less than or equal to 1, right? And also x square plus y square square root is less than delta. So it means that this is less than delta square. So what does it mean? X square plus y square into sine of 1 upon xy is less than delta square. Let us suppose that this is less than further epsilon. So it will give us the relation that delta square is less than epsilon or delta is less than square root of epsilon. So this is the relation between delta and epsilon. Again, I told you that we have assumed that this is less than epsilon. So I want to find out that what kind of delta we need to choose so that this difference is less than epsilon. So either I can assume it equal to, sometimes we use the sign of equality also. So we can choose because our main purpose is that this particular difference f of xy minus L, it should be less than epsilon, right? So if I say that it is less than delta square, so delta square can be equal to epsilon also or less than epsilon also. Okay, we can choose in any way. So this will gives us the relation that if we choose delta in this way, that either it is equal to or less than square root of epsilon, and automatically this particular value is less than epsilon only. So that is the required. Okay. Now let us consider one more problem. I'm trying to choose the different kind of problem to establish the result. So in this time I'm considering limit xy approaches to 0, 0. We have x cube plus y cube upon x square plus y square equal to 0. Now I want to establish this particular limit. So again, what can we do? So let del epsilon greater than 0 be any given number which is very small, where epsilon is very small. Again, we consider mod of f of xy minus L is less than epsilon. So what is your f of xy? This is your function f of xy and this is your limit L. So it means x cube plus y cube upon x plus y minus 0 is less than epsilon, or x cube plus y cube upon x plus y x square plus y square, sorry, right, is less than epsilon. So now again, let delta greater than 0 be any real number, such that 0 is less than square root of x minus x naught square is less than plus y minus y naught square is less than delta, and which also implies 0 is less than x minus x naught is less than delta, and 0 is less than y minus y naught is also less than delta. And here again the value of x naught and y naught is 0, 0. So if we choose x naught and y naught to be 0, 0, then we are given 0 is less than square root of x square plus y square is less than delta, which implies that mod of x is less than delta and mod of y is also less than delta. right? Now, again, we consider mod of x cube plus y cube upon x square plus y square. Now, in this case, x square plus y square is in the denominator, and we already have the condition for x square plus y square as it is less than delta. But it is in the denominator. That means if we take the reciprocal of this term, then it is in the greater than form. But we are expecting the expression of this one in the less than form, right? So in that case, it is not the easy task. So what can we do in this case? So we know that the neighborhood of a point is a circle. So what can we do? I simply convert the circle. Suppose that this is a circle. This is the neighborhood of a point x naught y naught, where the point is 0 0. Okay, and any neighborhood point, let it be xy. Okay, so I simply convert it into polar form. That means I join this point to this one, and I'm saying that this distance is very small. So because this distance is nothing but the radius, right? So if I say that this is r and this distance is x, this distance is y, and say this is angle theta. So what is the relation? So basically it is a right angle triangle. It is a right angle triangle of this form, that this angle is theta, this is x, this is r, and this is y. So x upon r, this is the adjacent to the angle theta, so it means cos theta. It will gives us x equal to r cos theta, and similarly perpendicular upon hypotenuse y upon r equal to sine theta. So the value of y is r sine theta. So if x equal to r cos theta and y equal to r sine theta, then x square plus y square is equal to r square. So it means that this condition now converted into, so r is equal to square root of x square plus y square. So it should be greater than 0 because the radius of a circle is always positive. So it means that the condition now reduces to r varies from 0 to delta. Okay. So what I'm going to do, I'm going to convert this Cartesian coordinate system into polar coordinate system. Okay. Now let us consider this again. So again, I can rewrite this as x cube plus y cube upon x square plus y square. So this is equal to r cube cos cube theta plus r cube sine cube theta upon x square plus y square is r square. So here you can see 2 power of r get cancelled out because r cube is common in the numerator, cos cube theta plus sine cube theta upon r square. So 2 power of r get cancelled out. So again, using the modulus property, that mod of a into b is equal to mod of a plus mod of a into mod of b. So this is mod of r into mod of cos cube theta plus sine cube theta. Now, but r is already positive because r is the radius. So it is r into, and here we can use the property of mod of a plus b. This is less than or equal to mod of a plus mod of b. So we get a sign of inequality, right? Less than or equal to form. This is cos cube theta, or we can write it as sine theta. Okay. And because we know that cos and sine, they are bounded function, and the value of cos theta is less than or equal to 1, sine theta is less than equal to 1, so is the value of a cube. So it means that this is less than. Now r is less than delta. R is already less than delta, but we'll do it in the next step. So I can write less than equal to r times 1 plus 1. So this is equal to 2r, but 2r is less than 2 delta. Let's say this is less than epsilon, because we have already assumed that f of xy minus L is less than epsilon. What is the relation between delta and epsilon? So delta is either equal to epsilon by 2 or it is less than epsilon by 2. Okay. So this is the relation. That means if we fix that, the difference between these two number is less than epsilon. So what kind of delta we need to choose? So we need to choose delta as either less than or equal to epsilon by 2 so that this relation is less than epsilon. Okay, so I think that with these problems you will get an idea that how can we apply the approach of the limit for solving the problem, and you can understand the concept of limit also, right? So soon I'll share with you the basic problems that how can we solve the problems of the limit and the continuity, okay, directly using the concept of limit only. Okay, so till then just try to revise this topic, and if you still face any kind of doubt or any problem based on this topic, you can ask me query or you can write it in the comment box. Okay, I'll try to provide you the solution for the same. Thank you. Till then, have a nice day.